Every few years, somewhere on Earth is witness to one of the planet's greatest sights, a total solar eclipse. A total solar eclipse is rare, but it can be calculated centuries in advance. However, that wasn't always the case. For thousands of years, solar eclipses were rare events that were considered to be bad omens. Learn more about solar eclipses, how they work, and how people have dealt with them throughout history on this episode of Everything Everywhere Daily. This episode is sponsored by newspapers.com, your passport to untold stories and hidden histories. As the largest online newspaper archive, newspapers.com offers an incredible journey through time, with papers dating back to 1690. Imagine exploring the news, events, and everyday moments that shape the history of the world around us. Newspapers.com puts over 900 million pages at your fingertips, offering a front row seat to the past. With papers from the United States, United Kingdom, Canada, Australia, and beyond, newspapers.com lets you walk the streets of history, whether it's London during the Blitz, New York during Prohibition, or Sydney during the construction of the Harbour Bridge. For listeners of today's episode, newspapers.com is extending a special offer. Use the code EVERYTHINGEVERYWHERE and enjoy a 20% discount on a subscription. That's Everything Everywhere at newspapers.com. It's the perfect way to unlock the world of history. This episode is sponsored by BetterHelp. We're already so far into 2024 that most people have already forgotten about their New Year's resolutions. But that doesn't mean the things you wanted to change have necessarily gone away. Most of us don't need to overhaul our lives completely. Most of us simply need to recognize and focus on our strengths. It isn't necessary to make extreme resolutions. You just need somebody to help you recognize what you're doing right so you can work on what needs improvement. BetterHelp is all about making professional counseling accessible, convenient, and affordable. With BetterHelp, you can connect with a licensed therapist from the comfort of your own home via online video sessions, chat, or phone calls. No matter where you are or what you're going through, BetterHelp is there for you. Just fill out a brief questionnaire to get matched with a licensed therapist, and you can switch therapists at any time for no additional charge. Begin identifying your strengths so you can work on the rest with BetterHelp. Visit betterhelp.com/everywhere today to get 10% off your first month. That's BetterHelp, HELP.com/everywhere. I'm sure that most of you know what a solar eclipse is, but we should probably start from the basics anyhow. When one astronomical object passes in front of another one, from the perspective of an observer, it's considered to be one of two things, either an occultation or a transit. A transit is when an object that appears smaller passes in front of an object that appears larger. For example, when Venus or Mercury passes in front of the Sun, that would be a transit. Venus and Mercury do not block out the Sun when they pass by. An occultation is when an object that is perceived to be larger passes in front of an object that is perceived to be the same size or smaller. This is also known as an eclipse. A solar eclipse is something that only happens on Earth in our solar system. It's when the moon passes in front of the Sun. If conditions are right, you can have a total solar eclipse, where the moon totally blocks out the orb of the Sun. The fact that we have total solar eclipses is ultimately just a cosmic coincidence. It just so happens that the moon appears to be the same size as the Sun from our position on the surface of the planet Earth. There are no other planets and moons in the solar system where this occurs. There will be times when the moon of a planet passes in front of the Sun, but that appears just as a transit. The coincidence of the perceived size of the moon and the Sun isn't just a coincidence of astronomy. It's also a coincidence of time. The moon is slowly getting further away from the Earth over time. Millions of years from now, the moon will appear smaller than it does and will be unable to totally eclipse the Sun. When the moon passes in front of the Sun, it casts a shadow that is much smaller than that of the diameter of the moon. The result is that only a narrow path on the Earth can actually see the Sun get totally eclipsed. Other parts of the Earth, because they're viewing it from a different angle, will only see the moon eclipse part of the Sun. There are several different types of eclipses that can occur. The first is the total solar eclipse that I've just mentioned, where the moon totally blocks the Sun. The second is a partial eclipse. This happens when the moon and the sun aren't perfectly aligned and only part of the moon passes in front of the sun. And then there are annular eclipses. An annular eclipse is when the moon and the sun are aligned, but the moon is slightly further away and isn't big enough to block out the sun. This happens because the moon's orbit around the Earth isn't perfectly circular. It's slightly elliptic. That means that at certain parts of the moon's orbit, it will appear slightly larger or smaller. That difference in the perceived size of the moon because of its distance from the Earth is enough to determine whether a total solar eclipse will occur. A solar eclipse can obviously only occur during a new moon. A question that many people have that is very reasonable is, why isn't there a solar eclipse every month? Shouldn't every new moon come with a solar eclipse? The reason why it doesn't happen has to do with the moon's orbit. The plane that the Earth orbits around the sun is known as the ecliptic plane. For the purpose of this discussion, you consider it to be a flat plane. The moon doesn't orbit the Earth along the ecliptic plane. Its orbit is slightly tilted at 5 degrees. That means that at some point during each month, the moon will be 5 degrees above the ecliptic plane and 5 degrees below the ecliptic plane. That's enough to ensure that the moon is usually above or below the sun when it passes in front of it each month. If the moon orbited the Earth in the ecliptic plane, then there would in fact be an eclipse every month. However, because it isn't in the ecliptic plane, the only time you can have a total eclipse is when the moon crosses the ecliptic plane at the same time it passes in front of the sun. And that is why eclipses are so rare. One of the interesting phenomena that can be observed during an annular or solar eclipse is what's known as Baily's beads. Baily's beads were named after the English astronomer Francis Baily, who explained the effects in 1836. The moon is not a perfectly smooth sphere. It has mountains and craters which create irregularities on its surface. When the moon passes in front of the sun, sometimes you can see the outline of the topography of the moon. Sunlight will come through the irregular perimeter of the moon, creating an effect that looks like beads of light. When a total solar eclipse happens, the shadow that is cast on the Earth is rather narrow, and this is known as the path of totality. Everywhere within the path of totality will experience the total eclipse, however brief. However, those in the middle of the path will experience it the longest. The width of the path of totality will vary, but it's usually about 100 to 120 miles or 160 to 193 kilometers wide. Because eclipses happen so infrequently, and because the path of totality is so narrow, most people will never experience a total solar eclipse during their lives, unless they go out of their way to see it. As solar eclipses have been occurring pretty much since the Earth was formed, humans have been experiencing them ever since there were humans. When early humans encountered an eclipse, they had no idea what was happening. The sun disappeared and the world went dark in the middle of the day, and it must have been terrifying and mystifying to ancient people. In many cultures, an eclipse was a bad omen. It could be interpreted in any number of ways, that something bad was going to happen, or perhaps that the gods didn't favor a particular ruler. The first record of a solar eclipse was written down on clay tablets found in Ugarit, Syria. The eclipse is believed to have taken place on March 5th, 1223 BC. Recording eclipses is very important for establishing historical timelines and calendars. Because the moon orbits the Earth in a highly regular way, it's possible to calculate the exact dates and times of historical eclipses. So, if we have evidence of an eclipse that occurred on a particular date on an ancient calendar, we can then synchronize that calendar to our calendar. There were records of eclipses from ancient China, Babylon, Greece, and many other cultures. While eclipses didn't occur frequently, eventually enough evidence began to pile up that some of the top minds in the ancient world realized that they happened on a regular basis. The Babylonians were the first people to record planetary movements and eclipses. They actually tracked lunar eclipses because they were more frequent and easier to track. With this data, they began to see regular patterns in eclipses. One of the landmarks in the study of eclipses took place 2,600 years ago. A Greek philosopher by the name of Thales of Miletus collected data from past eclipses and predicted when a future eclipse would occur. And this wasn't just a landmark moment in eclipses. This was arguably one of the first moments in the history of science. Thales collected data, created a hypothesis, and then made a prediction. His prediction wasn't what we would call precise. He simply predicted that an eclipse would take place during a given year. The eclipse he predicted was believed to have taken place in the year 585 BC. In fact, it supposedly took place right in the middle of a battle between the Medes and the Lydians. And supposedly when the eclipse took place, both sides stopped fighting and called an immediate truce. Attempts at predicting eclipses continued for centuries, but it wasn't until the 18th century that a true prediction, down to just a few minutes, was accurately made. The British astronomer royal Edmund Halley predicted the May 3, 1715 eclipse to within 4 minutes. Not only was he able to predict the eclipse, he was able to draw a map of the path of totality across England. Once it was possible to predict eclipses, it became easier to observe them. Given the short length of time where they take place, you need to be in the right place at the right time in order to get an observation. And that's hard to do when eclipses took you by surprise. The corona of the sun's atmosphere, was first identified during an eclipse in 1842. The first photograph of an eclipse was taken in 1851. And in 1868, a spectrographic analysis of the sun was taken during an eclipse, which determined its chemical composition. Perhaps the most important scientific observation to have taken place during an eclipse was taken during the May 29, 1919 total eclipse. It was used to make an observation which confirmed Einstein's theory of general relativity. Einstein's theory predicted that gravity could bend light. To measure this, it was necessary to check the position of stars near the sun and compare them to their positions when they aren't near the sun at different times of the year. However, you can't observe stars when they're near the sun because the sun is too bright. You can only do it during an eclipse. The amount of deflection measured in the stars was approximately 1.75 arcseconds at the limb of the sun, aligning closely with Einstein's calculations. With increased precision in astronomical measurements, eclipse prediction has become increasingly more accurate, and we now know when and where eclipses will take place years and indeed centuries in advance. Many people have become eclipse followers, traveling around the world to witness solar eclipses. And even if they don't travel around the world, many people will drive for hours just to see one that is within their area. In 2017, I made a trip to Nebraska to witness the eclipse, and we managed to view it right in the middle of the path of totality. It was the first time I had ever witnessed a total solar eclipse, and it was one of the most incredible natural phenomenon I've ever seen. And there is an enormous difference between being in totality and even being 99% eclipsed. When totality hit, it became quite dark immediately, and all of the streetlights turned on. If you ever have the opportunity to go see a total solar eclipse, I highly recommend you do it, even if you have to go out of your way to do so. The eclipse itself may only last for a few minutes, but it's something that you'll remember for the rest of your life. And it should go without saying that you should not look directly at the sun. This can do permanent damage to your eyes. If an eclipse is taking place, there will probably be plenty of cheap cardboard eclipse viewing glasses available that will block the vast majority of light and let you see what is happening. Total solar eclipses are relatively rare events that only happen on Earth, and millions of years from now, they'll no longer happen at all. They have mystified and fascinated humans for thousands of years, and will continue to do so for thousands more. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Benji Long and Cameron Kieffer. I want to give a big shout out to everyone who supports the show over on Patreon, including the show's producers. Your support helps me put out a show every single day. And also, Patreon is currently the only place where Everything Everywhere Daily merchandise is available to the top tier of supporters. If you'd like to talk to other listeners of the show and members of the Completionist Club, you can join the Everything Everywhere Daily Facebook group or Discord server. Links to everything are in the show notes.